Series connection of solar panels. Understanding the circuit. Benefits and usage. In a series connection, solar panels are linked end-to-end, where the positive terminal of one panel connects to the negative terminal of the next. This forms a continuous electrical loop, and the final output is taken from the remaining free positive and negative terminals at either end of the chain. When panels are connected in series, the total voltage of the system is the sum of the voltages of each panel, while the current remains the same as that of a single panel. For example, if each panel produces 40 volts and 8 amps, 4 panels in series will produce 160 volts at 8 amps. This configuration is commonly used when the system requires higher voltage to match the input requirements of inverters or charge controllers. It's especially beneficial in grid-tied systems where the inverter needs a minimum voltage to operate efficiently. However, one drawback of series connections is that shading or malfunction in one panel affects the entire string. If one panel is shaded and produces less current, the overall current of the series string drops to match the weakest panel. To mitigate this, bypass diodes are often integrated into panels to allow current to flow around shaded or faulty units. Series connections are also more efficient for long-distance power transmission, as higher voltage reduces energy loss due to resistance in wires. This makes them suitable for installations where panels are far from the inverter or battery bank. To summarize, a series connection is a straightforward method to increase voltage, reduce wiring losses, and match inverter input requirements. It's ideal for applications where shading is minimal and voltage needs are high. Benefits and use cases of series connection. 400 words. Increased voltage output. The most significant benefit of series connection is the cumulative voltage. This is crucial for systems that require high input voltage, such as grid-tied inverters or MPPT charge controllers. Higher voltage allows these devices to operate more efficiently and start up earlier in the day. Reduced wiring losses. Higher voltage means lower current for the same power output, which reduces I²R losses, or power loss due to resistance in wires. This allows for thinner cables and longer runs without significant energy loss, saving on material and installation costs. Simplified system design. Series connections reduce the number of wires and junction boxes needed, making the system easier to install and maintain. This is especially useful in large-scale solar farms or rooftop installations with limited space. Cost efficiency. By minimizing cable thickness and reducing the number of components, series configurations can lower overall system costs. This is particularly beneficial in commercial or industrial setups. Ideal for grid-tied systems. Most grid-tied inverters require a minimum voltage to operate. Series connections help meet this threshold quickly, ensuring maximum energy harvest throughout the day. When is it required? Grid-connected solar systems where inverter voltage requirements are high. Remote installations with long cable runs between panels and inverter. Large-scale solar farms aiming for streamlined wiring and reduced costs. Battery charging systems using MPPT controllers that benefit from higher input voltage. Limitations to consider. Shading sensitivity. One shaded panel can reduce the output of the entire string. Mismatch losses. Panels with different ratings or degradation levels can cause inefficiencies. In conclusion, series connections are best suited for high-voltage, low-current applications where shading is minimal and system simplicity is desired.